Good. Another physical quantity we look at is volume. Volume. What is volume? Now, volume is the amount of space occupied by matter. Oh. Now, the amount of space is confusing. Area, we say the amount of space, but we said occupied by the surface of the plane. But here now I'm saying the amount of space occupied by matter of an object. What is in that object, or what is in that body, is called matter. It's called what? Matter. So what matter occupies, for example, what your body occupies wherever you stand, how much space do you occupy with the whole of your body? Now that is your volume. So the amount of space occupied by matter is called what? Volume. And the SI unit of volume is cubic meter. Meters cubed. Cubic meter. Correctly read as cubic meter. And the other units. Other units of volume include cubic centimeters, cubic millimeters, liters, and many others. Okay, but let's get familiar with this. Cubic centimeters, cubic millimeters, liters. But the SI unit, remember, dear student, is cubic meter, and this M is written as a small letter m. How can we convert 1 cubic meter to centimeters cubed, or cubic centimeter? 1 cubic meter simply means 1 times 1 times 1 meter. So, and we know that 1 meter is equal to 100. So it says 100 centimeters times 100 centimeters times 100. And we shall get 1 million centimeters cubed. So therefore 1 cubic meter is equal to 1 million cubic centimeters. Okay, but also remember that 1 milliliter is the same as 1 cubic centimeter. 1 milliliter is equal to 1 cubic centimeter. Is the one originally being called as cc, cubic centimeter, the cc. So 1 milliliter, even this one said a mil, no, it is a milliliter. 1 milliliter is equal to 1 cubic centimeter, and 1,000 milliliters equal to 1 liter. 1,000 milliliters is equal to 1 liter, implying that 1,000 cubic centimeters, equal to 1 liter. But 1 cubic meter is equal to 1 million cubic centimeters, or 1 million milliliters. Let's look at an example. Express each of the following volumes in centimeters cubed. These are the ones to express. Okay, now 27 millimeters cubed, or cubic milliliters. 27 cubic. Now, 1 cubic millimeters should be 1 times 1. This is a mistake. This should be millimeter. M. 1 times 1 to make 3. So, and now, how many centimeters are in a millimeter? Or how many millimeters are in a centimeter? We know that 10 millimeters are in 1 centimeter. So if we are moving from millimeter to centimeter, so we divide by 10. So here we shall have 1 over 10 times 1 over 10 times 1 over 10. Okay, because 1 millimeter is the same as 1 over 10 centimeter. So but we have cubic, so we shall multiply 3 times. So therefore get that 1 millimeter cubed is equal to 1 over 1000 centimeters cubed, which is 0.001 centimeters cubed. So now if 1 is equal to 0.001 centimeters cubed, how about 25? Then we multiply by, well, how about 27? Then we multiply 27 by 0.001 cubic centimeters, and we get the answer 0.027 cubic centimeters. Okay, looking at the second one, we saw that 1 meters cubed 100 times 100 times 100, because this is 1 meter times 1 meter times 1 meter. In terms of centimeters, it is 100 times 100 times 100 centimeters. And of course we saw that we shall get 1 million centimeters cubed. So if we now have times 0.005, so we shall multiply this by 1 million, and we shall get 500 centimeters cubed. Okay, another example. How do we go now to meters cubed? Those two numbers, 9,000. Again we saw 1 meter cubed is equal to 1 million. So now here it will mean that we shall divide the 9,000 by 1 million. Okay, and we shall get 0.09 meters cubed. Okay, how about 27? Of course, this now simply shows that you divide the value by 1 million, and we shall get 0.00027 meters cubed. Meters cubed. Now let's look at the volume of regularly shaped solids. The volume of regularly shaped solids can be obtained by applying the appropriate formula. Now the table below shows some of the regular objects and their corresponding formulae for the volume. Now we're going to draw the table, and where we shall insert our objects so that we can look at the shapes of the objects. So we have here the object, and we have the volume formula, and we shall start with a cuboid. So I'm drawing here the shape of a cuboid or a box, like this one here, which has the dimensions length L, width W, and the height H. This is in the shape of a box. Now if it has all the sides equal, then it is called a cube. But if the sides are not equal, then it's called a cuboid. So how do you get the formula? How do you find the volume of this box here? The formula is L, the length, times W, that is the width, and times the height H. So simply L times W times H, which is length times width times height. And let's also look at something different, which is cylindrical. How do you get the volume of a cylinder? Now the cylinder has a circular surface of radius R and has a height H if it is vertical, but if it is horizontal, then this H can be taken to be the length, and we shall take that to be L. So the formula is given by pi r squared h. V is equal to pi r squared h. Now the pi r squared here, you know this formula of pi r squared is the area of the circle. Now this is the area of this circular surface here, or the area of the circular surface. So we multiply this area by the height. So pi r squared h times height, and we get the volume of the cylinder. Let's look at other shapes. Continue drawing in our table here. We're going to look at a triangular prism. Which takes that shape there. Which takes this shape. Now the base of the prism is rectangular. We have the width W and the length L. So this triangular prism, how do we get its formula, how its volume? We shall just get the base area, the area of the base times the height, the base area times the height. So for this case, what will be the area of the base? W times L, or length times width. We shall get the area of this rectangular base times the height, then you get the volume. If the prism has a triangular base, if for example you changed it and has a triangular base, then you just get the area of the triangle times the height, depending on the shape of the prism. But for this case, it has a rectangular base, so it is LW times height. And let's also look at the sphere. A sphere is something which is spherical. It's like a ball, basketball, netball, football. Those are spherical objects, and they have radius r. So the formula for volume of a sphere is given by 4/3 times pi r cubed. 4/3 times pi r cubed, or simply 4/3 pi r what? Cubed. This is the formula for volume of a sphere. Now let us look at examples. Example 1, a block of glass 5 centimeters long, 4 centimeters thick, and 2.5 centimeters high. Calculate its volume. That block, we can see it is it is going to be in the shape of a block or a box. So we shall just say L times W times width, and we get 5 times 4 times 2.5, and we get our answer as 50.0 centimeters cubed. The units are in centimeters. Example 2, find the volume of a cylindrical tin, 7 centimeters, radius 7 centimeters, and the height 3.0 centimeters. Again, in our solution, the area of the cross section, which was the pi r squared times the height. So we shall have the pi is 22/7 times radius squared, which is 7 times 7 times 3, and we get our answer as 462.0 centimeters cubed. I go further to other shapes. Triangular prism. If B stands for breadth, height, that's the height, and this is L. So we say that we shall get the cross-sectional area, or the base area, times the height, and the area we shall say, if it is a triangular prism like the one we saw above, we remember we just use this formula: 6 times 5 times 12, and we get 360 centimeters cubed. And lastly, let's look at the fourth example here, also about the sphere. Find the volume of a sphere whose radius is 3 centimeters. Of course, remember, say the formula is 4/3 pi r cubed. Just substitute, and we shall say 4/3 pi r cubed. Now, the 4/3 pi is 22/7. It can also use 3.142 times 3 times 3 times 3, which is cubed, and we shall get the answer as 113.14